Hey everyone. Super excited to be here. Tyler mentioned this is his sixth Meridian. This is my fifth. Not sixth because for one of them I was on paternity leave, so I couldn't attend. I was changing diapers. But yeah, I'm Senior Director of Engineering at the Stellar Development Foundation. And I wanted to kind of, as we're talking about passkeys and what types of things you can do with different types of accounts, I wanted to take a step back and just talk a little bit more about, and as I talk about it, introduce an opinionated way of calling some things, which you may or may not adopt. But we've always had accounts in Stellar, right? And I'm calling what we refer to traditional or classic, if you will, Stellar accounts as G accounts. Those are the accounts that have been around for 10 years. They look like that in terms of their address, right? It's that G address that you've probably seen multiple times if you've built in Stellar. What I really like about them is they're defined in the Stellar protocol. Their behavior is very deterministic, very well known, very well bounded. If I were to write a tagline for them, the account that everyone loves and trusts, right? Now, with the advent of Soroban, we've also introduced this idea of C accounts. So these are also referred to, not interchangeably, they're not exactly the same thing, but lots of people call them account abstractions, smart wallets, passkey accounts, many names that refer to this thing here, which is an account whose address starts with a C. And in building Soroban, we also, one of the decisions that were made is like every smart contract is itself an account. So C accounts are defined their behavior is defined as a smart contract. And this is a fully customizable account. So as we're talking about passkey wallets, passkey accounts, smart wallets, it begs the question, right? Like, what is wrong with G accounts in the first place? Are we trying to replace that? Is there a word for a G account? So what is wrong with them? Nothing. They're actually great. So G accounts are optimized for payments. You can use them to hold multiple assets via trust lines. You can perform DEX trades with the lowest possible fees. They have very mature standards for recovery and non-custodial sponsorship. So we have a wallet SDK that covers a bit of the key recovery and the sponsorship features for that too. And they have historically, for many, many years, great interoperability story in terms of cashing in, cashing out, regulated assets with SEP 8, which is Tomer's favorite SEP. They're awesome, right? I think the point in thinking about how we can evolve accounts to be defined via smart contracts is because any customization that has been historically done with G accounts, they are defined outside the trust boundaries of the Stellar protocol, which means they're not enforced by the Stellar protocol, they're enforced by standards that are defined a layer above, so to speak. So by definition, you're kind of increasing the trust boundary in a way that you can't necessarily enforce. There are other parties involved in something like SEP 8, for instance, right? It can sometimes, it's kind of like you put a transaction in the black box and it either gets approved or not, but there's no way for you to actually audit the code or make sure that things are going to behave in a certain way. So I think it's very timely that I'm talking about this after Tyler, right? Because he mentioned like the subscription idea, and I think I'm going to walk through how this could work in practice in a scenario where you want to use your G account as a way to subscribe to, say, a streaming service, right? So I know that the contrast isn't great there, but there are 4 swim lanes, which are the different parties that are involved in a flow like this. So user being the top one, that is you. Wallet, which is the wallet provider. The subscription service, which is the thing that you're trying to subscribe to. And the G account, which is the underlying structure on Stellar that is powering your subscription. So it all starts with you requesting to subscribe, very uneventful. And the first thing, or one of the very first things that a subscription service would request from you is actually for you to pay for that subscription. So in this flow where you're using G accounts and what I'm calling the naive approach, which is like the simplest one that I could think about, the wallet writes this transaction that pays 20 USDC from your account, your G account, to the subscription service. And you, as a user, because in this scenario, we're talking about a non-custodial wallet, there is that step in which you, as a user, review, approve, and sign that transaction, which in practical terms means clicking the button saying, like, OK, go ahead, I want to subscribe to that service within your wallet. The transaction is then submitted via the wallet to the Stellar network that confirms that payment. And once it's confirmed, success, right? Your subscription service has been paid. You're good to watch your movies on your streaming service. Now, the interesting thing is, for this naive approach, or like the simplest one, the next time that there's a billing cycle, say like every month, the subscription service is going to request that payment, and your wallet will build that transaction to pay 20 USDC. However, because you're the one in custody of the keys within your app, this requires you to actually open your app, review, approve, and sign the transaction again, which means you're in the critical path of the billing flow. And if you don't do that in a timely fashion, immediately when it requests or within a certain grace period, that means your service can be interrupted. And imagine you're paying for like your AWS bill. You don't want to get your services down because you didn't click on a notification that you might have missed. So is there an approach that doesn't require the user to open the app every time? And of course, yes, there are more elaborate solutions for that, while still leveraging something like a G account. So same flow, user, wallet, subscription service, and a G account. User starts requesting to subscribe. The subscription service, instead of requesting that you do one-off payment to the subscription service, it actually requests you to add themselves as a signer to your G account. And then the transaction that is going to be built by the wallet is a transaction to add S1 as a full signer. And the full signer, the full piece is very important, right? Because if you can do a payment on behalf of a user, you can do any type of payment. There are no restrictions, right? And you all know where I'm getting at, but let's bear with me. So you review, you approve, and sign that transaction, submit it, and now the subscription service is a full signer over your account. So they have access to unilaterally bill your account and withdraw those funds. So in this scenario, they're honoring what they originally requested, which is like the 20 USDC for that subscription payment. So of course, that's going to succeed. Now, Jake was talking earlier about the Dijkstra quote, right? Which is, if debugging is the right of removing bugs, then programming must be the act of creating bugs in the first place, right? So in this scenario, of course, there's a big chance that someone on the billing side might have written a bug, or say they were even malicious for that matter, right? And they decided off-cycle to send another payment, to draw another payment from your account. And in that scenario, they're a full signer of your account. So long as you have the 20 USDC, it's going to succeed, which it didn't want to happen in the first place, but there's no way to differentiate those two types of transactions because they're full signers over your account, unless you remove them as a signer, and then you're going to have a problem at the next billing cycle. So how can we limit what different signers can do, right? Is there a way to? And of course, it's a leading question. C accounts, yeah. They're awesome for that kind of use case. So C accounts, they have this function that is called checkauth, right, which allows you, as Tyler demonstrated, to create arbitrary policies that are assigned to specific signers. And you can be as specific as you want in terms of like what they can do with their accounts. So going back to my example, say you have a user, a wallet, a subscription, but the underlying account that you're using for this type of subscription is now a C account. So it's actually defined in a smart contract. So again, you're familiar with that. The user requests to subscribe. Now, the subscription, again, requests, hey, I want to be a signer in the account. With the difference being that the wallet, instead of adding this signer as a full signer over the account, it actually invokes this function to add S1 as a policy-bound signer, which means this is a signer that can do very specific things without your account and nothing else, if everything is coded right. So the user, again, reviews, approves, and signs. Of course, with Sorbonne, there are more details in terms of how you implement the simulation and all those things, but not to get too much in the weeds there. The wallet submits a transaction, and Stellar confirms, the natural confirms that S1 was added as a signer with restrictions. So when the subscription service bills within the parameters of what was defined in the policy, the 20 USDC from the C account, of course, that's great. That's what you wanted in the first place, success. Now, buggy code, for whatever reason, they decided to build this accidentally again, or for whatever reason with malicious intent, it's going to fail. It's going to fail because it's not within policy. And the next slide, I'm going to make a big statement. Bear with me. It's obviously my opinion, but I feel like this is a better experience than a debit card experience, right? And why I say that, first, you have full ownership over your funds, right? This is a non-custodial account. You're the sole holder of the keys of that account. The policies, as you define, they can be very, very specific, very fine-grained to exactly the behavior that you expect from that signer in terms of what they're using your funds for and how much of them. So, and the account owner can revoke policies whenever desired. So why this is interesting, right? If you give like a streaming service your debit card number, you're not necessarily limiting how much they can debit from your account, right? So that scenario that I mentioned of billing twice within a certain period that wasn't what you expected, they can still do that. Of course, you can dispute, open a dispute. If anyone has ever done that, it's not a fun experience. Sometimes it's very complicated, right? And in any case, it's a remediation, right? You're actually trying to recover the funds after the fact that they were debited from your account. But with policies, what you can actually do is you can be preventative. You can actually not allow the thing to happen in the first place, which is really awesome. And then the last point, the account owner revoking policies is really interesting because it means at the end of the day, depending on how you build this, all the policies are actually described in your contract, and you can see what each signer can do in your account. So that means you remember that service that you subscribed to years ago, they're still debiting on your card, you completely forgot about that, and then you need to come back and then realize, hey, they've been doing something here, I forgot to cancel this. With something as explicit as the policies being on your smart contracts, you have full tracking of all the different people who can do something on your account, and you can, at any time, just cancel the policy from your account directly. You should probably cancel the subscription regardless with the provider, but in any case, you know that that's happening, and you have that transparency. So again, I feel like this is much better than a debit card experience. This sounds great. Can we do that yet? Right? Is there anything that's missing? How can we make C accounts first-class citizens on Stellar? So I broke this down in a few different categories or things that are possible with G accounts versus C accounts, trying to cover like a comprehensive picture of like all the basic things that need to be supported. So of course, if you think about sending and receiving payments, both G accounts and C accounts are great for that, right? Like they're both designed in a way that this works pretty much flawlessly. I have this item here that describes a headless wallet, and I wanted to elaborate a bit on that because that's kind of a superpower. If you're here for Tyler's talk, he mentioned like no pop-ups opening, right? As you are actually creating a wallet or deploying a wallet. And that means for most modern browsers, they have support for passkeys. So in some ways, you can actually create a full experience on your dApp, on your Anchor, whatever you want, in which like you create a wallet for the user powered by passkeys that can be recovered without the user ever leaving the Anchor experience. They can actually. It's kind of like for them, it's very seamless. They don't even know that they're interacting with a wallet. And this is all possible because you can do this lightweight browser-based wallets, which you wouldn't want to do with a G account in the first place, because that would require asking people to take note of passphrases, or alternatively, I think you'd probably trust more downloading an app that manages your keys and have a way of recovering. So headless wallets is also actually a superpower of C accounts because of passkeys. Transaction sponsorship, we have a good story around G accounts. For C accounts, we have LaunchTube. That is kind of like a first iteration of what we can do there. In any case, you're able to create your own sponsorship story. It's not very complicated. So put it as yellow. It's not perfect yet, but it's definitely possible with not a lot of effort. Now, where it gets interesting, right, is fine-grained auth, right? So for G accounts, you can do that within certain limitations of using SEP8. If you're the issuer of the token, you can actually regulate with auth and de-auth sandwiches. It's kind of like maybe in the weeds here, but there's a way for you to regulate how assets are transacted. But it's not as flexible as C accounts, where you actually can control that at the account level versus at the asset level. Now, what I'm excited to talk about is, and I left those to the last, is our interoperability standards for cash in and cash out, right? So anyone who's used something like MoneyGram Access probably has been familiar with that flow where you open a pop-up and then you do your KYC and you get a code for making a deposit or a withdrawal, right? And so for a long time, we haven't talked about that for C accounts, right? Because there were a few things that we needed to figure out. But I think at this point, we do have a working version of this that I'm super excited to kind of show today. So how can I pause this? Is there a way? All right, so before we get there, I'm going to show like a wallet that is kind of like just a demonstration wallet, so you can have a good idea of, but it exposes a lot of the internals of what's happening, because it's kind of meant to be also like a teaching tool. So this is a SEP smart wallet, as we called it, right? Like it's a C account demo wallet. The first thing I do there is registering a passkey, again, native to the browser that I was using, no app download. I create a name for that account. I click on continue. I put my Touch ID. And then this smart wallet gets deployed. And as it gets deployed, you can see a C address that is associated with that account, hence C accounts. And that C address is going to be the public key, the identifier for my account. I'm going to set USDC asset as the asset that I want to actually go through a flow of cash in. You can see the reference to the asset on Sorbonne, right? And I'm going to start depositing with cash in. I want to say like 10 USDC is where I'm going to go with as a deposit. So this is actually going to trigger a SEP10 followed by a SEP24 flow. SEP10 is required for SEP24. So I'm going to have to, as part of SEP10, sign the transaction that identifies myself. And then I go to the pop-up. So this is not dissimilar from MoneyGram Access pop-up. And you can see the amount that I confirmed, but I'm kind of like within the realm of the anchor. I'm going to fill out some KYC information. Click continue. And this is a deposit flow, right? So this requires me to send an offline transaction and get tokens in exchange, right? So this informs me that the bank transfer succeeded, and you can see the deposit in progress, which is kind of like all the back and forth between the anchor and the wallet to confirm that everything is going through until the point that the transaction is actually being processed by the network. Like SEP24 happens for G accounts, but for C accounts. And you can see now that the balance is there. So yeah, pretty uneventful. I think that's kind of like the point here, right? It's super simple. The same experience that we were able to deliver with G accounts, now we can do that with C accounts. So that kind of bridges the gap on the things that were like super important for us to get this ready for prime time. So I put that as an alpha, and the reason why that is because we need you guys to tell whether we got it right or not, right? Like interoperability standards are only as good as how many people actually use the standards. So how can you learn more? We have this wallet UI on GitHub. That's a code, open source. The Anchor platform demo branch is also available on GitHub. And more importantly, the SEPs, the updates that we've done, we call that SEP 10C. We're kind of trying to figure out what's the best name for that. But that is where the new SEP is defined for authentication, which is kind of like the more meaty change that is required. For SEP 24, we also have the description here of what needs to be updated, but this one is relatively simpler because it's just changing the destination to be a C address. So super excited to show this firsthand here. Please play around with it. Let us know if we're forgetting anything or if things are not making sense. The more important part is for everyone to participate in this. And this is it. Thank you so much.